Yes, hey, thank you, thank you. I think what he's saying is what everybody is probably very sleepy and need a coffee right now, right? So thank you for bearing with me, and hopefully you can still get something from the conference. But first, I just wanted to maybe thank the conference organizers. That was a great opportunity for me to come to Berlin. I don't come very that often, so I could have a chance to play with tourists, and also you guys have this awesome event when you do like a 10K run with a first ray of sunshine at 4 o'clock in the morning, which I did, which is, you know, wonderful. Though people sometimes, well, Peter, why do you take yourself with cruel and unusual punishment? But anyway, I love this stuff. But now to our main topic. Now, how many of you here think running databases on Kubernetes is a good idea? Okay, some brave people and other saying that's not so good idea, no? Okay, okay. Well, that would be then good to, you know, to maybe convince you, or maybe not. Now, for folks who are running the databases on Kubernetes, which databases is that? You know, anyone? Postgres? MongoDB? Okay. Anyone else? Okay. Well, cool. That is just, you know, for information for me, not particularly blaming anyone. Well, here is why my case about why I think running on databases on Kubernetes is important. While it's may not be always easy, it is as of right now. I think that is, you know, good thing to do. Now, any one of you had seen this kind of an image of AWS advertising themselves and comparing themselves to electricity? Right, that is now, you can see even from the logo, is kind of quite old, right? Maybe, you know, 15, 20 years ago when people were just getting adjusted to the idea of cloud. Well, at that time, the cloud was promising us, hey guys, you know what? It is like electricity, as you can see here, right? Like, well, it doesn't make sense for most of it, us most of the time produce your own electricity. Or, yes, we can, right? But usually it's much more convenient, you know, reliable, better just to get that from utility, right? And that is, on one extent, was a promise on the cloud, but that is not what Amazon or any other cloud vendors would do, right? The thing of electricity is its commodity. You know, I can take that, you know, laptop which feeds off electricity and take it around the world, plug into any outlet, and it just works, right? Now, if you are looking for a lot of technologies which you guys like Amazon wants you to use, it's a very much cloud specific, right? That's vendor lock-in, and that comes with a whole bunch of, you know, problems which may range from, you know, the costs, right? Or it can come from, you know, the politics, right? I think here in Europe, right, you know, hey, how can we have our sovereign technology or whatever, right? Seems to be the big topic on recently. So I think with that, it is important to see how we can use the clouds, right, for all aspects of our infrastructure as a commodity, so we can, you know, use the convenience of a cloud and maybe their efficiency in certain ways, but don't get in that vendor lock-in situation, right? And the Kubernetes is one of technologies which allows us to do that. Now, you may say, well, but Kubernetes was designed for stateless applications, right? And this is, of course, true, right? But I think as with many technologies, what it's designed for and what it kind of goes into, that is very different, right? I started, for example, with MySQL. And I remember in the early days, it was said that the MySQL will never ever support transactions because transactions are evil and bad for you, right? Now, so many years later, well, believe it or not, majority of workloads which use MySQL are using transactions, right? And it has a pretty robust transactional storage engine called MongoDB. Kind of the same goes with Kubernetes, right? If you look at Kubernetes, we're actually the community folks have organized data on Kubernetes, which is a very focused on the best practices, how to run those data-intensive workloads on Kubernetes, right? And it has been, doing pretty well and driving a lot of efforts, to really continue to solve the problems in Kubernetes, right? This is something which I grabbed from DOK Day, right? When I had a presentation, and I think that's an interest in some feedback here, right? For the pool they did, what you are looking at very kind of significant number of people believe that Kubernetes is ready for stateful workloads. So not like you, there are some believers, right? And also there is a significant number of organizations which are running stateful workloads, especially databases, right? Now, I don't have a slide for you today in this presentation, but actually was also a pool what people who actually dare to run the database on Kubernetes, so other stateful workloads, right? So generally happy with outcome. It often kind of goes better than their firm would do. Now, what is also interesting, if you look at a lot of modern database as a service solutions, right, are actually using Kubernetes in the backend. We just had a couple of sessions ago, Manish from ClickHouse spoke here as well, right, about them using Kubernetes in their cloud as well, right, and it seems like quite successful, even though, right, they highlight some problems, right, and they have to, do certain things, right, to make it work well. And I think that is exactly what it works with Kubernetes, right? If you just say, hey, you know what, I just don't want to think about it. I don't want to configure my Kubernetes, right? I want to just, to throw a database on Kubernetes. Well, you may be up to bad surprises, right? And with a database, the bad surprises can be really bad surprises. Because in many cases, if you have your application, you kind of screwed up your deployment, well, you can redeploy it, right? In many cases, quite easily. With a databases, if you trust your databases, well, it may be problematic, right? You may not have a backup, or you may have a backup which is kind of a few hours old, and there is kind of a gap with that data you have to reconcile, right? All that kind of a messy stuff with a sort of like a number one job of a database is not to lose data in many cases, right? And that sort of like limits options. Okay. With that, let's move on to their Kubernetes best practices. And again, those are going to be relatively high level, but I think as with many things, if you get the basic things right, you can be often, like better than 95% of people out there, right? I think that's like in everything in life, right? You can see, oh, we need those kind of, advanced stuff, but when you look at the overall number of folks, majority are not, just doing the basics. Okay. So the first one is, if you're running database on Kubernetes, you want to use the operators, right? Indeed, you can take a database like, hey, I take the, MySQL or Postgres container, throw it on my Kubernetes, and hey, I got the database. And that's maybe fine for development, right? If you want to play with it. But if you really look at a lot of real databases, right, you want them to live for a long time. A lot of databases, right, they're sort of in production for many years or decades, and have to kind of always stay up, maybe kind of to go for short maintenance and kind of never lose data during that period, right? So, and Kubernetes operators, that is something which provides the support for that kind of life cycle. How you can scale the database when it goes wrong, right? How it provides availability, healing, often the backups and restores, right? That can be happen embedded as the operator framework and so on and so forth, right? So use operator, sometimes there are number of operators on the market, right? And in this case, you want to make sure to use the operator which is mature, well supported. Not something like, hey, this was my weekend project, I dropped it on GitHub, please use it. Because again, database is not something you want to mess with for production workloads. Next one is you really want to have a high availability setup. Right, because if you're not thinking through high availability, Kubernetes is not really going to take very good care of you, right? It's not like your, bare metal server, right? And unless you do something with it, it's kind of going to, hum along for maybe many years, right? You can have various events like, pod being evicted, rescheduled, right, and so on and so forth, right? So to make sure it is set up with high availability for all kind of production deployment. Third one is, if you look at your data, right, you need to make sure what you have that data persistent, and that means is what it is stored on persistent volumes. Right, not stored inside of that kind of container which you deployed, because if that container is destroyed, for example, you're doing with the upgrade, guess what? The data which is inside that container is gone with it. Here you can see two approaches applied. Right, one, you can say, hey, I am using some sort of fast remote storage. Right, if you look in the cloud, that's it can be EBS or something like that, which is reliable, but that's and it also gives you some high availability, right, from like a node failure, disk failure, right? It has a built-in redundancy, but that's also relatively slow and relatively expensive. And then you also have local disks, right? Those can be very fast, awesome, and cheap, right? If you look at, let's say, AWS with some NVMe storage, awesome, right? But in this case, you especially want to set up the high availability correctly, right? Just to make sure what if a node dies, then you lost all the data with it, right? So option. The next thing is keep data per pod small. Now, what you think in this case is interesting, if you look at the bare metal and a big iron became really big, right? We can really have hundreds of CPU cores, right, in the bare metal, right? And a terabyte plus of memory. That can allow us to operate a lot of data in that iron, right? But that is not what the Kubernetes and its best practice is designed for. Right, so if you can say, hey, I want to run my 50 terabyte in Kubernetes, and that will have to be in a single pod because my database doesn't support sharding, well, it may not be a good choice right yet, right? Like you want to have a smaller, manageable, data sizes. So if you need data to be reprovisioned on different pod, maybe kind of copied from one volume to another, right? That can happen in, acceptable period of time, right? Like typically we see that, again, it depends on the network configuration and a whole bunch of stuff, but I think, single terabytes are doable. Then you also want to make sure you are using appropriate nodes sizes. This is also interesting, right? You see a lot of Kubernetes environments out there which are deployed for small stateless applications. They are often cut in relatively small VMs or nodes, right? Now, with a database, you may want to have a bigger ones, right? Because databases typically, many of them, right? They use a lot of resources, a lot of memory, right? And what that means is we often would see somebody saying, hey, yes, I'm running a database on Kubernetes, but my database, which I use for database, is actually going to be different than one I use for my sort of like a normal stateless applications, because it uses a different kind of nodes with a different kind of different parameters, right? Like maybe it's kind of faster backend networking if I'm using this, storage, because that's going to be intensive, right? Or whatever. So I think that is important. Number 6, you also may want to configure resource requests and limits. And I would say for production, you want that both. Now, when you look in development, you often don't think about that stuff. Hey, I got a database, it got provisioned somewhere, and then like I use relatively light load, and I'm don't really care how consistent that is, right? Now, what happens if you provision in a database where you configured, let's say, only request, but you did not configure limit, right? Well, chances are, well, it will get provisioned on some node, and you will get a lot more capacity than you expected, right? And you or developers will get used to that, saying, "Oh, look at that! It's actually I only ask for 4 CPUs, and it actually performed awesome, right? But actually, Kubernetes scheduled you somewhere and you have 64 CPUs. Now, as the load on that cluster increased, then you actually only given what you asked for as a request. You may have your performance, drop into 10x, right? And that happens during the night in the worst possible time, right? And now your application is down. You don't want to deal with that, at least from operational point of view, right? So that's why you often make sure for things when it's kind of important, performance critical, you match requests and limits, right? So your database is has that uniform operations if that is important for you. Then you want to make sure you have set up a proper anti-affinity rules, right? What do we mean by anti-affinity? Well, you have 2 pods which have a copy of your data, right? And you want to make sure they don't go down at the same time. If they happen to be scheduled on the same physical server, that's going to be bad, right? Well, depending on how you think about your availability, that may be the same rack is bad, or like a same availability zone in the cloud is bad. You want to configure proper anti-affinity rules, right, to which matches what exactly your failure modes you want to support, right? I think by default, right, in many operators we say, hey, you know what? At least we'll prevent you from scheduling them on the same node. Next one is, of course, you want to tune your database, right? Well, Kubernetes does no magic as it comes to this, right? And a lot of the database problems, they come from the database configuration and tuning, which I kind of say very broadly here, right? You want to make sure, of course, you have a proper database configuration. You want to make sure you have all the proper indexes set up, right? You also want to make sure is what you are not throwing stupid queries at your database, because the rule is, right, if you really want to write a very horrible, terrible query, you can write query which no database with no kind of indexes would be able to run efficiently, right? It's kind of like if your developers really want to DDoS your database, right, they can. So make sure they don't, right? Now, I can highlight here at Percona we have the tool for that. It's called Percona Monitoring Management, right, which has a lot of insights in terms of how to optimize the database. This is their open source tool. You can just download and use, right? Doesn't require any kind of commercial relationship with Percona to do that. Next, you want to understand how to scale your database, right? And this again may look like a trivial. For if you are, for example, PostgreSQL expert, you say, well, of course, that's how it goes. But from many developer standpoint, they don't really quite understand it and say, oh, well, I have this kind of, 3 nodes PostgreSQL cluster, and if I throw a query on it, it's going to, of course, use all of them to execute that. Well, maybe not. And if you have a MySQL, well, and a server, right, and you have, for example, 64 CPU cores, right, well, you throw a query, it wouldn't be able to use all of them because single query execution in MySQL is kind of single-threaded, right? So you need to understand that. Now, at the same time, right, as a gentleman mentioned, as he runs MongoDB, well, in MongoDB you can actually scale by sharding, which is kind of built in technology, right, and that's kind of your standard way of scaling the database. Now, in MySQL or Postgres, there is no built-in sharding, though there are, let's say, some external solutions which can give you some of that, right? But it is kind of not built in. So that is something which I would really want to highlight. And it goes beyond that, right? Like, for example, if you look at using, let's say, MySQL replication to scale. Let's say I have one primary, let's say 5 secondaries, right? Well, guess what? I still bottlenecked on all my write queries with that, right? So I cannot scale writes, I can only scale reads with replicas. Again, all those kind of things is not there, and Kubernetes doesn't change anything. So why am I even talking about that? Well, because Kubernetes abstracts more things from you. If you are setting up, let's say, I'm setting up a MySQL replication, right? You are kind of setting that explicitly, node replication. You have to kind of get to understand how it works. In a Kubernetes environment, often you don't. I am just, provisioning MySQL cluster with 5 nodes. I have no clue, right, what exactly it works and how, right? So that, I think, gets more of those kind of misunderstanding in this case. The next one is you also want to control eviction with a pod priority, right? Because when you kind of evicted the database, it is expensive, right, to get it back, right? Let's say if you say, hey, I just killed their MySQL and I had the persistent volume, I just reprovisioned that on much nicer, bigger box. Oh, all good. Well, what needs to happen? First, the MySQL will have to do a crash recovery because you killed it. It will take time, right? Then, after it does a crash recovery, it will have to kind of warm up, right? Because the previous instance had all that stuff in memory, right? So it will take a time to reach that performance, and you do not want to, mess with that. You don't want to kind of happen. You want to make sure database engine is ready for that because it will happen in Kubernetes environment, but you don't want that to happen, too frequently because that's more disruptive. Then there is security, right? Well, again, nothing is kind of changes here, but I think it's again open up to a different kind of the exposure, right, which you can achieve in or get in Kubernetes accidentally, which you cannot in other the environment. And exposed database is so common. If the database itself or backups, so think about that. For backups, well, specifically, we also would recommend to enable encryption, right? If your database support data trace encryption, that is a very good thing to enable, because with modern CPUs, encryption is not very expensive, right? It's not very expensive to kind of to encrypt and decrypt your data if a database is set up correctly. The same goes with a data in transit encryption, especially if you have like persistent connections. That doesn't give a lot of overhead, but gives you a lot in terms of security. In many cases, you also may be required to do that for compliance reasons. The next one in terms of security is using Kubernetes secrets. And a lot of operators, they have sort of integration with that, so you can use them to provision some users automatically, right? And also use for that, because again, if you are sort of using more of a kind of conventional way, hey, let me put the the unencrypted passwords in some configuration files, or pass them some other way that may not be the most secure way to do it. The backups. Well, this again pretty simple and same as in the same as with your other environment, right? Remember what some sort of clustering and high availability does not eliminate needs from backups, right? Because good, fast replication will ensure if somebody drops a table, right, or trashes your data, it's very quickly replicated to all the nodes as well, right? So you want to make sure what you have the backups set up. Again, good operators make that very easy, right? So for example, if you look at Percona Operators we provide you both like a full backups as well. We can have a binary log shipping, so we can essentially every like a few minutes we also upload to S3 or something your binary log files, right, which allows you to get that backup recovered to a pretty recent state, guaranteed. Now, a lot of here has been said about the databases which are very popular, but they are also very old, right? If you think about MySQL or PostgreSQL, these are not cloud-native databases, right? They are not even designed to be distributed databases. These are databases designed for this kind of a concept of like a single node and kind of scaling up paradigm, right? And so they do have challenges, right, despite their popularity, right? And I think what is very exciting in this case, very interesting, what we also have a new generation of database which is designed for a cloud, right? Like I think we can see both databases or technologies like VTAS, which sort of like a packages MySQL in that kind of more cloud-native format, right? So we have technologies like Yugabyte or TiDB, which are databases which are designed to be distributed from ground up and work very well in Kubernetes environment. Next is CPU choices. Well, I think that is very interesting, like in a Kubernetes environment where you can get a lot of choices, right? Especially running in the cloud providers. What we see, and I think that especially can be seen with many cloud vendors those days, right? Which provide you managed X, is their usage of ARM CPUs, right? That's often for certain databases. Can you get better performance at lower cost and power, right? So that is something which I also suggest to evaluate, right? Especially because in many kind of cloud they kind of try to abstract away those days, like how many vCPUs are you going to have, even though there can be quite a lot of difference in performance, right, for those. Next, you can think about their Kubernetes deployment. And here we see people successfully having a different choices, right? Some people say, hey, okay, we are using Amazon, right, and they like their managed Kubernetes offering. That's kind of awesome. There may be some restrictions what you cannot do, but also that means we don't have to. Well, we offload some responsibility on that team. Some other people say, hey, you know what? We would like to have our own Kubernetes distribution. We deploy it on-prem on different clouds. We want that to be consistent. Both approaches can work, right? I just would suggest here to make sure you think about that. Next one is the utilization. So one thing Kubernetes also gets kind of very easy, and I think that's kind of also with a cloud, is to get a lot of resources. Right, you often can even kind of set up your Kubernetes after scale, which kind of may get your workload scaled over many loads, which creates a lot of waste. Right, that can be it can be problematic, right? And especially if you look at a database, that can be especially problematic because, as I suggested, hey, we want to often use a beefy load, beefy nodes, right, which can be expensive, and often we also have they configured in a way you have a single pod scheduled on those database more to avoid the interaction with sort of like nosy neighbors, right, and stuff, right? So that have some potential issues, right? Can be even more profound, right? For example, if you say, hey, I have moved to a larger configuration, now I need so much resources, but I have some nodes which are smaller than that. Well, nothing can be scheduled on them, right? Because they're too small and they're only in that database cluster, provisioning now some big pods on them. Okay, now let me also maybe highlight from Percona sides, what do we provide for best practices, right, to help you running the databases on Kubernetes? One is we provide the operators, right? These are typically kind of not the only operators, right? There is other ones for MySQL and for Postgres, right? But we have some of the more mature one in the ecosystem. For example, in MySQL, we have created operator, probably like 3 years or so, right, before Oracle had came up with theirs, right? Also, our MongoDB operator is kind of pretty awesome, and it doesn't kind of integrate, doesn't kind of require any kind of bits and pieces from the MongoDB Enterprise Edition. But this comes to the Kubernetes operators, right? And as I mentioned, hey, running Kubernetes operators are awesome. But at the same time, if you look at many of those cloud vendors, for example, which use Kubernetes, besides they use something like a Kubernetes operators, but typically not just that, right? Because while for some people, Kubernetes UX is awesome, right? And it's like, hey, infrastructure as a code, and whatever I need to do, I just, change my resource definition in, YAML and provision, commit that, and then deploy it, and I have all the history, what I changed. I can roll back, and it's kind of also awesome. But then there is also a large group of users who prefer ClickOps to DevOps, right, or GitOps, right? Like they like that sort of like experience where I can deploy a database in a few clicks, right? And with that, you can see that's why services like Amazon RDS and such are very successful. You can see also a lot of organizations now are having some like a platform teams, and they're building developer platform which maybe run on Kubernetes, but allows developers to just deploy the database, right, if you want it, through UI as well, among other things. Well, and that is also like something what we at Percona are working on, right? We have a project which is called Percona Everest. Again, that is an open source project which provides you UI kind of, which is rather similar to what you would see in Amazon other cloud vendors. Let's say, hey, I want to provision like MySQL, the first version, right? It will do all the kind of magic with Kubernetes, right? You can configure automatic backups and so on and so forth, right? So again, that's like an open source project. If you guys want to, check it out, provide some feedback, or maybe even commit some code, that would be appreciated. So, and the other project I want to mention, it is not about the database itself, but it's about observability. And this is project something I'm personally involved with. It's open source observability tool which is called Karoot, which I find is very helpful in a Kubernetes environment, in particular when you are deploying the operators. Why? Is because it's really good at exposing what is really underneath. Because often you deploy a Kubernetes operator, there is a bunch of components out there, right? Like if you think about like a Postgres, there is going to be maybe, Patroni for high availability, and there is going to be, something for, as a load balancer, right? And there is going to be multiple nodes, right? How are we going to talk to each other? What is master, right? Or whatever. Kahoot can help you to look at all of that, as well as it has some, some other rings, bits and pieces which are quite helpful, ranging from understanding your costs to highlighting risks, right? If you have some database which was exposed through like a node port on Kubernetes, right? It's able to say, hey, are you really sure what you want to do that? Yeah. And we also have on this conference the founder of Kahoot, Nikolai Sivko. He will be talking tomorrow, right? If you want to learn more about that project, then here you go. And with that's all I had to say. And I think I have about 3 minutes for questions.
Thank you. Thank you, Peter. Any questions? Yeah.
Hi, thank you for your talk. I have a quick one. I'm not sure if this was mentioned, but in those databases like PostgreSQL or MySQL, right? Mm-hmm. Like we are talking about Kubernetes deployment, and they are not designed to work with like in multi-node setups, right? Like in general, so what I mean is, let's say we attach a volume to a cluster, right? And then on that, and at the same time, we want to keep, let's say, high availability, but we don't want to have actually 2 pods of that database running and potentially writing to the same location.
Of course.
So how do you manage that situation?
Well, I mean, again, that is what like operators would manage that for you, right? So what you would look at this case typically, it's kind of the same, right? If you look at MySQL or Postgres, each node is expected to have its own copy of data. So you would have each of the nodes will have its own persistent volume with its own kind of copy of data. Right, so that's how we would do, right? And now, if your node fails, then the operator will say, "Oh, look at that! That's just like a compute node which failed, but I still have a persistent volume, right? I can then provision a new compute node and reattach that volume to it, right? So that's kind of one of the logic, right, which operator needs to take care of.
But that means that you had to implement some kind of replication between them as well, right? So yes. That the state on both is...
That's right. Again, I mean, if you look at this case, well, think about this, right? If I want to deploy highly available Postgres or MySQL on a bare metal, right? Well, I will have to replicate, set up a replication, set up a failover, right? All of the things manually. Right, there is no way around it. Right now, the thing is what in the Kubernetes environment, all of that stuff is implemented for you inside the operator. Right, so it will do, as you say, set up a replication for you. It will do, high availability and so on and so forth. Right.
Okay, thank you.
Welcome.
Another question? No. Yes.
Yeah, you mentioned that, like database workloads, they kind of prefer having big iron, like big pods. Mm-hmm. I guess kind of how do you reconcile with that other recommendation that you said 50 terabytes is too much? I mean, like, I don't know if you have like a 64 core,
That's right. Well, that's right. That's a question of a balance, right? Well, my point here is you can get, let's say, up to a certain point, right? Because there's like going to be, network limitations and some other stuff, right? Because what you want typically is can say, okay, I am, let's say, provisioning a new database node, right? It needs kind of, let's say, copy of a data, right? Whether that's going to be, cloned through a snapshot, pulled off from like a backup in S3 and caught up, whatever. But you often want to have some requirements how long it's going to take. If you say, hey, it's 50 terabytes, I need to scale, right, to go from 3 nodes to 4 nodes, and it takes me a week, that's probably not going to work out. right? So that is going to be kind of those operational requirements often is going to kind of require that, right? Now, you may find in this case, so to get the best performance, you need, for example, there like a 64 core, with, so 256 gigabytes of memory, something of, like a mid size. Now, if you say, and that's also reality, right? It's some say, well, you know what? We only provision pods with 16 cores and 64 gigs, right? And that is what our ops team configured. That's how our Kubernetes cluster looks like. For your small apps instance, that's maybe fine, right? And then they say, well, you know what? That means if something dies, like single pod dies, it cannot take a lot of shit down with it. But if databases, that may not be enough, right? That means you may not be able to get a proper performance. So that is what I mean. Does that make sense?
Yeah. A follow-up for that. What about, have you had any experience with having like pods where you have a lot of persistent volume claims, like lots of volumes attached to these big beefy pods? Do you see that as an anti-pattern, or is that just a way to scale out to get more like throughput on those big pods?
Oh, well, I mean, I cannot really comment a lot right about that. I've seen people saying, well, you know what, if I get multiple, let's say EBS volumes, right, then I get more throughput. Some people do that. I would also always look in this case in terms of how that plays out with that, cloud provider or hardware, because there have been a lot of changes, right, in those cases. For example, how much IOPS you can get from EBS in Amazon now, or let's say 3 or 5 years ago, is very different, right? So I think that is always kind of, hey, if you're having some of those unnatural things because of the limitations, check if those limitations still exist.
Thank you.
Thanks. Any other question?
Yeah. Thanks. Thanks for the talk. Might be a quite specific Postgres question, but you might be able to generalize that. We are heavily using the Zalando Postgres operator, and I wanted to know, if you could say a few words, why would we want to use the Percona operators instead of other existing database operators?
Yeah. So, well, if you look in my opinion, right, right now, right, and we at Percona, we looked at having using Zalando operator, right, in like as a base for our, right. The question in this case, in terms of their how well supported and what's kind of a long-term commitment from that is has been a question, right? Because that is like a work with few guys. I know some of them change a company. That is always a question, right? And that I think is also a thing with databases. Databases are very conservative. For many companies, making a database peaks, these are your peaks for next 5 years, maybe like decades plus. You want a guarantee, right? Now, if you look at my take in a PostgreSQL, there are, if you look at the open source, there are 2 operators which are good, right? One is Percona Operators, right? Then there is a Cloud Native PG, right? These are kind of both operators with like a sort of like a commercial backend, right? You have a lot of kind of paying customers relying for them, right? So companies are likely to maintain that for a long time, right? In this case, yeah, there also has been the like a crunchy operator, but that kind of is sort of tricky, right? It relies on the images which you don't have access, which are kind of not available unless you have subscription. So it's kind of tricky setup. And also, like, well, Snowflake just bought Crunchy, so I mean, yeah, it's a question of what will happen to their open source posturing.
Thank you.
Thanks. Let's thank the speaker. Thank you, Peter.
Okay.